Okay, anytime you see the integration symbol, and inside there you see an x to the raised -1, we don't want it written like that. To the -1 power is the only one where we're going to rewrite it as, I'll bring that -4 out. Whoops, not parentheses, but the integration symbol. And this is indefinite, so we'll have the plus c as part of our answer. So instead of writing it as x to the negative first, rewrite it as 1 over x dx. And then ask yourself, what function's derivative is 1 over x? ln of x. So f of x is equal to -4 ln, but because when you take the log or natural log of something, you cannot have a negative number. You have to put the absolute value, instead of parentheses, put the absolute value, bars around the x, and then plus c. So every time in the integration you have an x to the -1 and only -1, you rewrite it as 1 over x. And then here's how you check. What is the derivative of, so here's f of x is ln of x. Let's ignore the -4 for just a minute. Well, f prime of x, well, the derivative of ln of x is 1 over x times the ln of e, and it cancels. And the derivative of c is 0. So there you have it. And that 1 over x is x to the -1. The only thing we didn't add is that -4 there. You could add it there. All right, I'm going to move over to e to the x. All right. We'll pull out the constant, and then you have e to the x dx. Well, remember, if you have y is equal to e to the x, the derivative is e to the x times the ln of e, which cancels, times the derivative of x, which is 1. So e to the x, the derivative is e to the x, and if you go backwards, it's still e to the x. So when you integrate, bring the -3 down, and the integral of e to the x is also e to the x, and then plus c. And you don't really need to put that in parentheses. You can, well, kind of you should, but normally you don't see it that way. -3 e to the x plus c. Just like that. All right, we're going to go ahead and do so now you've got this base that's not e, so it's not the same. Remember, if you have b, I'll call this g of x, right? So if y is equal to this exponential, say base 2 or base 4, or whatever the base is, the derivative is the original times the natural log of the base times the derivative of g. Well, when you're working backwards, you have to think the opposite of that. So let's do this example. We'll pull out the -3, and then we have 5 to the x dx. So when you integrate, it's the original divided by ln of 5, because when we differentiate, we multiply. When we integrate, we divide. And then if g of x, let me think about how that would work. I will do a different video. I'll find one of those and I'll do a different video on one of those, because right now that would be too confusing. We're just doing an intro, but I'll find one more complex. And there you go. That would be it. Remember, it's not -3 times 5 mean 15. The 5 to the x, in order to multiply this exponential, this would have to be a 5 or a multiple of 5. Okay, and that's it. And then we'll do the trig ones.